on Open RAN, a cost-effective and quality alternative, ? We're going to be discussing a very exciting topic today, and we have three excellent participants. We have Oguz Sune, we have Saad Sheikh, and we have Sven Freudenfeld. And let me ask each of our speakers to introduce themselves, starting with you, Oguz.
Hi, everybody. My name is Oguz Sune. I'm the VP of R&D at Open Networking Foundation. We are basically an operator-driven open source consortium driving intelligence and disaggregation to various aspects of the telco industry, including the mobile domain.
Thank you. Sven?
Yeah, welcome everyone. I'm glad to be here. My name is Sven and I'm the CTO at Lana Electronics. We've been investing in white boxes for the last 4 years, stretching between multi-access edge computing, SD-WAN appliances, and also the focus on Open RAN appliances.
And Saad?
Thanks to Layer 123 for having me. I'm very excited to be part of this thoughtful discussion. My name is Saad Sheikh and I work as Chief Architect within Infrastructure Planning and Architecture Design team of STC. So our team main role here is to define the complete infrastructure all the way from core to the edge, evaluating all these distributive architectures. So we are actively looking towards the Open RAN as the future technology to build over last mile.
Cool. So let's start by, I think it's be a good idea to define what we believe Open RAN to be, and in particular how it is distinct from what people are calling vRAN. Maybe we can start with you.
Sure. I guess when we think about Open RAN, as the name suggests, we start with openness. So we have to define what we mean by openness. And that actually also it comes in hand with using cloud computing principles, bringing that into the RAN. So the fundamentals of cloud computing says, whatever you can, you should pool. So that effectively brings in the notion of disaggregation for the RAN. Identifying the different components and laying out the architecture in such a way that some components start pooling others, and we have a hierarchical distributed cloud infrastructure. And the openness that we're talking about there then is clearly specifying all of the interfaces between all of these disaggregated components that we have. And it is the interfaces that need to be completely open so that actually we not only go towards an architecture that resembles the cloud and brings in cloud economics, but it also allows for a multi-vendor deployment. Now, the second aspect of Open RAN, which is just as important, is to bring in intelligence. Today, the mobile link is one where we are actually utilizing perhaps the most important resource that operators own, which is the spectrum. It is the most expensive resource. And today, the intelligence that we use to control the RAN resides within what operators get from vendors. And you're confined to the level of intelligence that you get from those devices. Disaggregating that and bringing in, again, open interfaces between the intelligence and the devices that you're controlling will fuel the innovation towards more efficient spectrum usage and better service for everybody, which in turn will come back to the operators in more revenue streams and better CapEx and OpEx.
Thank you. So Sven, maybe I can ask you to define the components into which Open RAN is decomposed and where the interfaces are between the CU, the DU, the RU, and so on.
Yeah, for sure. So so starting with the radio unit, right? It's basically mounted in the vRAN environment. It was typically a proprietary design and owned by a specific vendor. In an Open RAN environment, that's shifting towards sort of a commercial off-the-shelf approach, towards the openness, as said before, to really focusing on a software-defined architecture. The second level beyond that is the distributed unit, and the distributed unit could be spread all over different locations. Yeah. The distributed unit requires a few specific interfaces or compute resources to be able to be mounted in some of the cabinets as well. So the first point being in a certain form factor footprint, also what type of processing resources are going to be available. That could be it's not a standard data center server, what you normally know what has been deployed in the data center. There are some specifics, and since we are a strong partner with Intel, I can say there are some processors queues designed specifically to manage the workload using an x86 environment, but also to do a processing offloading using either an FPGA or perhaps a GPU in the future. And then the centralized unit is really bringing it all together in sort of an aggregation point of view, right? Where before you hand it over to, let's say, an evolved packet core, virtual EPC appliances. And on the aggregation point, it's really important that the traffic load can be very dynamic. Even if you look at multiple infrastructure elements, we don't start from a greenfield. We started from a brownfield deployment. So that means that the existing 4G environment needs to be intact when we're moving towards 5G, right? And there needs to be scalability, and we've been heavily involved in new technology like P4 networking programmability for dynamic workloads, and yeah, so these are elements where white boxes are coming into play. But again, it's not your standard average server. It needs to have specific functionality, including precision time protocols, because on the radio side, it's important that you keep a synchronized network with that.
And maybe just as a little background for people who are not so, the ORAN Alliance was formed in a partnership with the XRAN group that had been very focused on open front haul, because the CPRI interface for the front haul had been extremely expensive, really needing dark fiber, and had really held up the ability to distribute the RAN. I don't know, Sven, if you have any comments on the importance of the open front haul for the fiber connectivity.
Yes, of course, it's an important factor, but we in our approach, we're looking at sort of a white box approach, right? So x86 agnostic appliances, which can really focus on the software-defined approach. Right?
Okay. So Saad, what are you, as an operator, what are you looking at as the requirements that the reasons you're looking at Open RAN from a service provider point of view?
Yeah, absolutely. I think how we jump into this Open RAN or Cloud RAN thing, I think the prime reason we see it from the hardware point of view, because we know every 5 years we have been replacing these RAN boxes, and somehow we find there is no flexibility. So actually our management first expects to see it from purely on the hardware infrastructure perspective, to see, because the vendors, I remember the last year when we started over 5G, they were saying they have some boxes which is supporting Cloud RAN, but they're bringing their own boxes. So our prime aspect is to really see, because if they are saying they are supporting x86, so how to standardize, I think for our procurement and to build the overall aspect of the infrastructure, that's the key thing, or the key driver, right? But during the last year or so, we have seen, because we already built the cloud, we have tried to automate it within our core data centers. But now we are trying to extend it towards the edge, right? So naturally, we really want to see that this cloud RAN thing, how we can fully automate it or to bring it forward. However, I mean, this is, I think, the key thing, how we are trying to see it, right? Because we want to deliver the whole infrastructure, till the end 5G side, right? Through the IP and through the same models, whatever we are building. However, as a brownfield network, we find certain challenges, right? Because you know that in the traditional RAN networks, the most important thing for a telecom operator is the RAN requirement itself, which today we think is quite heavy and rich. We know that how the traditional telecom vendors have played. They drop the prices of their customized boxes, but they try to give too much features on the RAN. And if we do a deep down analysis, we as an operator, it's very hard to see what we use, what we will use, or what is so somehow I think that is very important to make a very realistic view if we really want to be successful, or move to the real capacity based model. I think the RAN requirements is going to be the top driver, right? And following by the migration strategy, I think that's very important. We need to see today there are at least 5 to 6 different combinations on the RAN, on macro, indoor, femtocells, nano, where it makes best, because we really want to find a green field or a place where we can experiment it in a real environment, to make it work and move it from there, right? And obviously, as I told you, programming and automation is very important. Why it is becoming more and more important? Because, for example, specifically for us, our management say to deploy some AI or data-driven use cases. And we are searching across the whole infrastructure. We have done something successfully on the marketing or a business side. Now we touch the infrastructure. And I think RAN is the most important piece for us to take this value out, right? And we should not forget, it's not something just like the automation or RIC, but we have to see the networking and SDN side as well. This is very hard to build right now, how we will build the SDN at the edge to bring the connectivity to the last mile. And that is why we see Open RAN and this CPRI interfaces, because as I told you, we need IP till the end to manage it in a seamless way. So I think that's the thing. And obviously cost is one attractive thing from our top management. But from the architect side, I think this is how we are trying to build our RFX. And this is the key drivers that we are trying to narrow down our funnel to move forward.
So I'm hearing flexibility, upgradability, reusability, and then overall management ability to automate the whole management and deployment of the whole system. So Oyus, is that what you see from many of your operator members, or are some of them just really driven by the cost aspects?
So cost is of course important, but what we have been hearing from our operator partners is that cost is definitely not necessarily the driving force towards their pursuit of Open RAN. I think there are multiple dimensions, and maybe indirectly the other dimensions translate into cost, but at the core of it, I think there are a couple of really important things that they would like to be able to achieve. One is with disaggregation, now there is the follow-up question. Okay, you disaggregated the RAN. Are you still going to be confined to a single vendor? Or can you actually mix and match? And that multi-vendor dimension is very, very important for the operators. I mean, I know operators who are actually going out in the near future for Open RAN deployments or lab trials, where one of the fundamental requirements that they have as a starting point is that they want different vendors for RU, different vendors for CU and DU. Now, whether that is achievable from day one is another question, but that is one really important issue that they're looking for. And the second one is, again, intelligence. They want, we have been talking about SDN, bringing in SDN into the RAN. And ONF is the birthplace of SDN. So, so we spend a lot of time with the operators in that dimension as well. And that effectively means applying SDN principles. And what are they? At a very high level, the control of the mobile link today it takes place in two hierarchies. There is some control elements that are distributed across the base stations. And then you have the self-organizing network components that look at the network holistically. But the self-organizing network components are all proprietary. So effectively, what you are trying to do is to turn all of this into an environment that promotes innovation towards more intelligent, machine learning driven control of your RAN environment. And that effectively means going learning from our adjacent technologies of computer networking and cloud, and having a platform, a controller platform, on which you can realize the different aspects of RAN control as applications running on that platform. And that is what operators really ultimately want to see with Open RAN. And that is the big prize. And everything else is icing on the cake.
Let's come back to the controller in a little minute, but let me ask Sven, from the decomposition point of view, are we ready to decompose the CU and the DU and the RU? Or do we have the hardware and the horsepower available to do that? Or can we only do the CU for now and the DU maybe next year or so?
So from a compute resources perspective, definitely there are components available. And as I said, Intel has a big push on that using an Atom-based family, the P series, which is public information, which is really optimized for the distributed unit, but also the controlled unit. It has capabilities for traffic management built in. So these are all new functions on a standard x86. The challenge I see is that the acceleration part of that, because the acceleration is typically either an FPGA or graphics processor. And that's where it's dependent on the software part of it operating as a disaggregated module. As it was said, when we try to build in artificial intelligence and machine learning, some of the elements of the hardware platform need to be able to support that. I mentioned P4 before. P4 is a programming language which leverages some of the elements, in particular a feature set which is called in-band network telemetry. And this telemetry data is very important to reduce latency throughout the network, especially at the DU and the CU side. So these are the elements, but we see the most important ones. But I think in the longer term, there will be some dependency on the actual acceleration technology.
That's very interesting. I heard I was listening to an ITU machine learning conference that I've been listening to, and China Mobile was talking about their attempt to automate their 5G RAN, not yet Open RAN, but one of the big issues they had, even with their huge data set, given how many cells they've deployed, they still are finding it hard to get a large enough data set to automate because of the geographic variation. And it would seem like that telemetry application would be an important input to automation.
Yeah, and the other aspect is, where do you do the processing, right, for machine learning and artificial intelligence? Do you move it over to a centralized unit or even the aggregation point? or as a centralized unit, because it does add latency, right? So you need to have some capabilities to do processing for AI and machine learning right at the edge, and not pass all the traffic all the way across the network.
Right, right. Yeah, that's a real challenge. So Said, I don't know if you've been following Rakuten. We were discussing, I was interested, Rakuten is largely a 4G, or has been a 4G network until now when they're deploying 5G. But I wrote a paper in April on their experience, and one of the things that came out, and they were very open about it, is because they had adopted this multi-vendor approach that Oyuz was talking about, they found the systems integration costs, which they'd originally contracted with Cisco, but they ended up doing it themselves, became quite significant when you go into this multi-vendor environment. Are you, I mean, so as a result, are you looking to go with multi-vendor up front, or are you maybe looking for a pre-integrated or pre-tested Open RAN to start with?
Yeah, absolutely. First, I think in the operator community, the Rakuten is the famous boy. I think everybody is following it. But I think we need to learn the lessons from them in a very pragmatic fashion, right? Because as I told you, because for me, I always take this Open RAN as an extension of the cloud, right? To unify the hardware, just like Sven was mentioning, to analyze how we can make it unified, something which can make us whole life easy, right? And automate it in a common fashion. But really, if we see from the RAN side, the deployment model, that is very important to see, with the different type of site configuration, different environment, to see what is the right way. Where we see today, obviously we want to achieve, I think Open RAN, let's say in a decade or 5 years time, for sure, it will force operator to become the self-SI itself. Why? Because I think that there will be a redefinition of a supplier definition as in today, right? Or the outsourcing model, because you see, irrespective like on the core and cloud or the central sites, in RAN is a pure managed services model for the operator. And this is how we are doing. And the staff are less skilled, and there is a many field teams. So ultimately, if we see a brownfield, we have to see the deployment model. And today it only makes sense to bring a expert system integrator to get its job done. But the fact is this, we see the companies who are promoting as a SI on the RAN, but you see the situation of the big three. I don't think so they as of now have a very big or good relation with them, because they are also coming with their own definition of open. And you see how the situation has hampered our progress in NFV, because we see all big players joining cloud and they say we are open plus, right? Yep. We are open and also 1, 2, 3, 4. Now we want to get rid of it. And this is what, even this Kubernetes or this, we are always promoting, okay, I just need open, something working and something which will be mature or stay hardened over time, right? So that's very important, how we can bring these big vendors to be controlled by them, okay? And obviously to see a new model on the software, because I just don't want, because you see the situation, there is one new SI player coming from the automation or SI. I don't think so there can be, somehow one player who understands the RAN itself, because RAN is a complex game. It's 3GPP, deep specs, and this spectrum sharing and how the radios are being handled. So somehow in the phase, I think that is gonna be an evolution path. And pre-validation solution, I think that is a must as of now. We want multi-vendor, but for sure there should be a clear method to certify it, not just certify the hardware, complete solution, okay? And with the radio KPIs, which we can show to the RAN teams, to see the transport teams, to see if it is adding value and evolve it in this fashion. I think that's the take, and this is something even with the Open RAN in the TEEP initiative, we have been collaborating, bringing partners and key players and the operators within the region to really see and go into the RF space to really keep this ball moving in this aspect, right? So this is how we are seeing it and approaching it.
Interesting. Is ONF trying to help? I've seen the development around Rakuten of a set of players. Telefonica is developing a set of players. Vodafone has a set of players. Dish is developing a set of players. Are you seeing clusters of ecosystems? And is ONF trying to play a role in getting the interoperability working?
Absolutely. So there are a number of players in the Open RAN ecosystem. So there are these new vendors that are coming in. There are the incumbent vendors. And then there are some very interesting new entrants who are just focusing on different aspects of this disaggregated platform. I mean, we were talking about automation, for example. There are vendors from the traditional cloud industry who are coming in with their automation platforms optimized for RAN. They have been doing their homework around that. And then there are some really interesting companies who are just there to bring in intelligence. So they are looking at specific control applications and developing those. So you know, open and maybe behind closed doors, there is a big ecosystem that's brewing. So that's a given. And around that, we were talking about the importance of interoperability. I think along with ONF, the ORAN Alliance and TIP are getting together and with tier 1 operators. One recent one is Deutsche Telekom in Berlin. There are new conformance testing labs that are being opening.
The TIAC labs, or yeah.
Exactly. So effectively there, you know, in the Deutsche Telekom case, for example, I have read the news. In the first phase, the whole conformance is going to be all about the front haul. So you are going to have multiple vendors coming in with their devices, and Deutsche Telekom, along with ONF and TIP, is going to do conformance testing.
Great.
And then,
great.
And then in the next phase, the focus is going to be all about that intelligence that that I was referring to before. So then there's going to be multiple control platforms, and you can even call those platforms as sort of the RAN operating systems. So just like iOS and Android, there are going to be open and closed platforms, but then running on that are going to be the RAN control applications. And these conformance labs are going to actually fuel innovation in that intelligence part. I can easily see some output coming in from universities and some new startups popping in, focusing on just one aspect of the control and bringing in their applications in those conformance labs and making sure that everything interoperates. So I see great future for Open RAN, and I agree that it is a complicated domain, and the disaggregation and the desire for multi-vendor is making things even more complicated, at least on paper. But this brewing ecosystem, along with these conformance labs and the use of open source as a baseline for all of this is, I think, are all steps in the right direction towards realizing our goal.
So Sven, as an independent player, are you finding that you have to work with a lot of different people to get the interoperability testing done?
So, well, we've been working as a white box in the SD-WAN space for the last four years. So we have learned quite a bit. We created our own ecosystem with a broad spectrum on expertise. So we have, you know, companies who building a universal CPE framework for an orchestrator, and then deploying different VNFs on an enterprise SD-WAN appliance. It's pretty much a similar setup on that. So we have been investing in a lab as well, because hardware is, you know, is always more a challenge ship to customers or for trials to complete the validation and testing. So we've been teaming up with Intel heavily on this, and we're building out a lab which provides open source tools, including the Intel openness framework for the orchestration and control. And on the other thing on the SD-WAN side, we did pre-validation with our partners, and that's really the benefit to the service providers. By the end of the day, as was said, right, they want a solution, an open solution. So they don't just want to buy piece and bits, which may or may not be working together. So we try to shorten that time to revenue by working with the ecosystem.
You want to mention which vendors you've been working with?
Oh,
if it's public.
Well, yeah, public is on the SD-WAN side. We have, working with companies like Adva, Equinox, many others, 128 Technologies. These are all really players in SD-WAN and University PE.
Yeah.
And we have been in discussions with companies like Mavenir, Casa Systems, and so on for, the open RAN initiative as well.
Yes. You mentioned the RAN interface controller, which has always, and up until recently, I guess there was just Radisys and a reluctant Nokia. But now that I think I heard there was a new vendor entering the market, there's some new independent players coming in, but that is one of the hardest things to optimize with the scheduler to really achieve the performance of that precious spectrum. I mean, that's really the big object. I used to work for Motorola. That would be the place that the big vendors are going to say, that's really hard, guys.
Yeah. That's very true. So there are tiers of RAN control. So we have to first do our homework in that classification. So there is the real-time aspect of it. You mentioned scheduler. I would label that as a real-time control. Okay. And then there is the near real-time control, which would be more, for example, as you are going through handovers. That would be less delay stringent than the scheduler component. And then there would be even more relaxed delay loops, which would be about load balancing, for example, across multiple base stations. So when you actually start classifying that, then you have to realize that this centralization story, the SDNization story where we are bringing into RAN, doesn't necessarily, at least in the beginning, doesn't necessarily attempt to lift the real-time control components from the distributed units. It is the near real-time components that you are. So, for example, use handover as an example. Traditionally, right now, the handover intelligence myopically looks at one handset, for example, your handset, and based on the experience of your handset makes a decision. Yeah. But the minute you centralize that handover algorithm, then as you are actually going through your mobile path, through big data, the network now will have, the entire look of what everybody's doing.
Interesting.
And then a very different type of handover intelligence can start coming into play. Yeah. One that is machine learning driven and etc. So it is that aspect that is going to really fuel the innovation.
Yeah. So actually some enhanced intelligent functionality that can't be done in a single vendor who doesn't have access to all the information. Interesting. Interesting. You mentioned SDN. Are there any end user capabilities related to the use of SDN, or is that just for the network assignment?
So, I mean, at this stage, of course, you have to have 3GPP compatibility for base stations and handsets to interoperate. So, at this stage, the control is going to be confined to the control of the base stations, or the RUDU CUs. But maybe with 6G or 7G, handsets are most likely going to come into picture, but not anytime soon.
Yeah. But we are starting to see things like RAN slicing or RAN, RAN being part of an end-to-end network slice. And so that's going to be really important to guarantee end-to-end class of service, so quality of service.
That's very true. Actually, I'm glad you brought that up. Prior to ONF, at one of my prior positions, I actually developed the world's first trialed RAN slicing solution.
Oh.
So that actually, again, using a centralized control, you can actually do a hierarchical control for RAN slicing. So the RAN slicing at the core of it requires you to dynamically partition the resources across different verticals. And that effectively means getting your hands dirty inside the scheduler. But at the same time, there is a configuration aspect of it. Based on operator policies, you want to be in real time able to control the dynamicity and what you allocate in terms of flows or devices into different slices. So what you can do is you can actually, with a compliant DU, you can realize the slicing on the DU and use that controller that we are talking about, the near real-time RIC. You can configure that in real time.
Oh my! Now, I was always taught you don't mess with the controller. Two guys in a room in the dark of night figure that out, and that's. But as we get into more dynamic systems, and especially your point about automation earlier, so 5G just cannot be managed in a non-automated fashion. Let me ask if you see small. I'm hearing small cells are coming back with Open RAN. We're going to,
yes.
How do you see that happening?
I think we were talking about brownfield versus greenfield, and in the context of Open RAN, that is very important. So we are talking about the Rakuten success story. Dish is coming, and both of those networks are greenfield networks. So they don't have the baggage of 2G, 3G, 4G. But for other operators, tier ones and tier twos, which are still going to have to deal with a brownfield setup, like we were talking, new greenfield verticals would be a good starting point for Open RAN. Yeah. And that effectively brings in, especially when you think in the US, we have the new CBRS band. Yes. In various parts of the world, we have now these new spectrum allocations specific for enterprises. So that brings in, actually that ties Open RAN with a private 5G network, which is an incoming and potentially really big revenue vertical for operators. And in those, so far, small cells or in the previous incarnation, femtocells have been very, very limited in use. But with these new spectrum and the need for the enterprises on their path towards Industry 4.0, the need for automating the machinery, the processes, 5G is going to play a big role. And there you can actually do Open RAN probably in a much easier way as well, because your automation is confined to an enterprise location, and the geography is much smaller and limited. So there, small cells and Open RAN are going to play a very, very big role.
So not for densification, but for essentially an island. Yeah.
So there, the whole issue is going to be towards the needs of the enterprises, providing these ultra reliable, low latency communications and machine type communications, and being able to actually do that in a scaling way. So you mentioned densification. Densification is going to still play a big role, because if an enterprise is moving towards automation, that means it is going to actually start deploying lots of sensors. And so we should stop thinking about just handsets as in 5G.
Yeah,
So
yeah.
if you have IoT devices, even in a reasonably sized factory, you could be talking about potentially hundreds of thousands, if not millions, of IoT devices.
Interesting, interesting. And so let me ask you all to comment on the timing, where we really are on the time curve. So let me start with you, Saad. You know, where are you in terms of starting to look at it? I saw a very interesting estimate from Enrique Bianco of Telefonica that he was now, who was just announced a partnership with Rakuten, if only to learn what they're doing, because they have very different vendors. But he was talking about, you know, some volume in 2021, but real volume in 2022. Saad, is that the kind of time frame you're looking at, or do you think it might happen sooner, later?
I think the realistic timing will be from 2023, which is the mass scale, you know. But ultimately, we need to really figure out this journey is aligned with our requirements. So I think, especially in 2021, we first want to understand the clear definition of the Open RAN, the deployment models, the pre-validation, and like we need to really at least go into the RFI type of scenario to see the industry capability, because as we see, we all agree, right? The architecture is what fits us, right? But when you totally disaggregate things, it's very important to see the capability, right? How you will deploy this on a mass scale, how to manage it, and how to take value out of it. So I think 2021 is more about this. In 2022, I think we can expect some pilot deployments and some maturity in the solution. For sure, the solutions are available today, but I doubt about their maturity and deliverability, like how it meets in a brownfield. And so this is something in 2022 we can see really hardened way of do things. And then from 2023, I think it will become a mainstream if everything goes well. Well, for example, within the Open RAN and RIC, because we are trying to see it from many views, right? For sure, there is one open source view which just was sharing. Then there is some, I should say, a pessimistic view coming from the RAN and this brownfield guys. And then there is some other operators' journey view, which we're trying to harden in the form of tape. So somehow we need to converge all of them, and then we can take it forward. But just you know, I just want to share, at least because in the last 1 year we were more in the R&D phase. You know, we are collecting all the BOQs and studying them one by one. One thing I can safely say that Open RAN is real, but I don't want to say too much support it without building something, feel it in a realistic way, you know, where I can see, you know, some results which we are expecting in the Q1 of next year or Q2. We're trying to grab some real information of our field trials and requirements. Then I think we will take it, you know, according to define objective.
I was going to say, if you believe in the hype cycle, I've actually found over my career that when you get into what they call the trough of disillusionment and everybody starts talking negatively, that's actually when the market is really starting, because people are really working on it. And I like to remind people that's when the exponential curve takes off for real adoption. So we have just come out of the hype cycle, I think, in many ways. But when we start to hear really bad things, that means people are really working on it. So let me ask you, Sven, where do you see the market timing from your point of view?
So I think from a carrier perspective, the challenge is that they have the existing 4G infrastructure in place and they need to build up to roll out 5G. I think what we see is really an area for greenfield. So we are involved in something called the Rural Cloud Initiative. Which is bringing basically the 5G infrastructure for the private 5G infrastructure to the rural areas. So the FCC has allocated a significant amount of funding to build that infrastructure for smart farming and smart agriculture. And that's where all the machine learning and artificial intelligence fit into this as well. So this is a real, true brownfield, bringing this to the farming community. And I think that will be the first one where we really have not to deal with an existing infrastructure as a greenfield. And we see, I think this will be the first one who will take the advantages of an open RAN infrastructure, and I believe in 2021, starting in 2021. Okay. So they will be way ahead of the curve than traditional service providers, because there is a need for that to build out that rural infrastructure with 5G.
So are we ever going to put the RUs on the tractors and have a truly mobile infrastructure?
I don't think on the tractor, but the infrastructure needs to be there to sustain that, right? Normally, the rural cloud initiative is working with many carriers to bring the services.
Yeah, much needed, much needed.
Correct. So, so that infrastructure and the openness needs to be there as well, right? So you need to have an open RAN framework in order to take advantages of multi-vendor, multi-carrier environment.
But the farmer could be plowing 3 fields at the same time with 3 different tractors, right? Like machine controlled tractors.
I'm not a farmer, so I won't comment on that.
Well,
but
off-road vehicle control is going to come before on-road vehicle control. But I know they.
Correct.
Anyway, so
latency is a big challenge on that in the rural cloud initiative, because you want to keep it closest to the edge as possible.
So, are you optimistic here, or are you what should we say, conservative?
No, I'm very optimistic. So we have been talking. We started our session with the definition of Open RAN. So at the core of Open RAN is this disaggregation of the base station into lots and lots of components, right? So we can view that disaggregation in 2 dimensions. One is going to be the RUDU-CU dimension, and the other one would be the SDN dimension. So if we actually think of it in these 2 dimensions, the first cycle with deployment is going to come with the first dimension. So the RUDU-CU, and even that is going to come in stages. So we may actually start with, true CU disaggregated from co-located RU and DU. So that may be a starting point. And then disaggregate the DU from the RU. And that is going to actually come a lot sooner than we think. Well, we have already seen a success story with Rakuten, and undoubtedly there are other new greenfield or some progressive operators who are anxious to get there. So I believe in 2021 we are going to hear from certain operators the first Open RAN, the first version of the Open RAN in production. And then it is going to actually stagger from there. And for me, I would say the true SDNization will come probably around 2023 or so. Okay. But between now and 2023, we are going to be focusing on the front haul and then the F1 interfaces and ensuring that that's stable. And then we are going to start worrying about the E2 interface and the controller platform and the applications. So I think we are going to look back in maybe 2024, 2025, and see what we have today as a distant past. It's going to come quickly.
Well, what you're saying is that because the architecture is disaggregated, we can actually make a lot of progress on specific interfaces, get those really
Exactly.
working, interoperable,
Exactly.
and then move to the next. It's not the whole system has to work out of the box end to end.
Exactly. It's not binary. These are Lego blocks, if you will. And you can actually start disaggregating at your peril. So different operators, depending on how, I guess, conservative or progressive they are going to have their own timelines. And again, depending on the priorities, the timelines or the sequence at which they do that disaggregation may differ from one to the other. But I think we are going to hear more and more disaggregated RAN solutions in production based on open interfaces as early as next year.
So we just have a couple of minutes left. So let me ask each of you to just say, what is the key takeaway you would like our audience to go away with, and what action they should take in the next year? Let me start with you, Saad.
Yeah, I think for us, I want to give a message that Open RAN is real, but to take the real value out of it, I think we need to take, as an operator community, active interest into this. This will really help us to make a clear delivery model and to manage the whole infrastructure, because we are today talking about telco and IT merger of the cloud in the core. If we are successful in this, I think this will really change us in a real, what you call, digital service provider. And for this, we should be more, I think, open, sharing our experiences, collaboration, and optimization along the path. I think that's very important if we really want to achieve a very optimistic vision from us. Because still, I believe that as we go into more and more production or commercial deployment, that integration of knowledge across different layers, as I said, the 3GPP layer, because for us, there's like we need to convince the transport guys, they come up with a transport mindset and the IETF view, and then the another guys coming on a radio or a spectrum or an RF optimizer. So to bring the whole herd together, it's very important for the success, and we should not miss this opportunity and time to build this funnel going forward.
Great. Sven, your key takeaway?
Oh, key takeaway is that disaggregation will continue. It's proven already in other areas in the network where there are cost savings as well, time to revenue. So commercial off-the-shelf appliances is the way to go, and work with an ecosystem which can operate on these different type of platforms. So that's with generic trends. So as I said in the beginning, we started on SD-WAN. We see disaggregated cell-side routers also as a disaggregated approach, and the Open RAN will follow the same direction.
Great. And Ayush, you get the last word.
All right. So this is part of the general transformation story for the telcos, right? We are effectively turning the whole connectivity network into a distributed cloud paradigm, so with different types of compute and storage at different hierarchies. And in that setup, the logical thing to do is to disaggregate both the RAN and the core, and then find the correct placements of that. So that is, I think with 5G, that is going to become a reality. So as such, Open RAN is definitely a reality, and every one of us should be accepting of that. And the next thing that I would like to stress is when we say Open RAN, today the focus might be on front haul, but the jewel of Open RAN is the SDNization of the RAN.
Yeah. And I have often called this the PC revolution for radio. So with that, let me thank our great speakers and wish everyone a good day. And let's all hope that by this time next year, we'll see a lot of progress in Open RAN. Thank you very much for your excellent discussion.
Thank you.
Thank you.
Thank you. Bye.
Bye.